Alright, so I want to show a quick example of a curve multi-axis toolpath. Curve is sort of the contour of the multi-axis group, in my opinion. Um, I guess it would be, in a way, the simplest if we pull down. It isn't the first one. To me, it is the simplest one of all of these multi-axis options. So we're going to stick with curve for this first one. And again, this will be the first time we get into simultaneous 5-axis machining, although this is very simple. But more importantly, on the the UMC has, to my knowledge, it comes stock on those machines. But on other 5-axis machines that Haas carries, I'm not sure about other makers. I know they also have a similar option. But they call it tool center point control. And tool center point control is the simultaneous movement equivalent of dynamic work offsets. So you have DWO and you have TCPC. So the previous example that there's a video on, that's all dynamic work offsets. All right. This example will show tool center point control. All right. So we'll show that in the post when we get there. So right now, let's just create the chamfer. I'll go to solids, and I'm going to go to chamfer distance, and I'm just going to select this face and hit green check, and we'll get a chamfer. All right. 50 thousandths is fine. Green check. So now, I'm going to save. Now in the new toolpath group, I'm going to go over to toolpaths, okay, and we'll get into curve. But before I do that, planning ahead, I want to use some 2D geometry on the top here. I prefer that for this example only because I like the ability to control where the start point on the chain is. And the easiest way that I'm aware of to do that is to use regular 2D geometry. So to do that, we're not going to draw on it. We're going to go over to wireframe. We can also do a new level if you want. I'm just going to make 3 active. I had a blank level here for additional, just the 2D on the outside here. All right, I can clear those. I don't need that, so I'm going to end up deleting entities on that level. Okay. And now what we'll get into is, since this level is active, level 3, this can be chain for curve, something like that. Okay, we could go to curve one edge and select these edges, and that'll just create a piece of 2D geometry. Okay, that we could reference. Now that's a lot easier than trying to draw on there. So again, that was curve one edge. So now we're in toolpaths. We'll get into toolpaths up on the top here, and we'll select curve. Okay. Now this is the 1/8 inch engraving tool from last time. I have a 3/8 tool in there now. We'll end up calling this tool 2. All right. And I'm not really worried about the speeds and feeds for this one. Again, I'm just trying to show you the basics here, and this will be I don't know, curve, something like that. Okay, or chamfer, whatever you want. So we'll go down and select a holder, and that holder's fine for this. It has 8 inches of clearance. That's fine. That's more than enough for this one because we're only going to be tipping about 45 degrees. So we could edit the tool projection to like 1.5 inches, and that should work. The stock's going to be irrelevant here. The cut pattern. Now, there's a lot more going on here. The cut pattern for this one controls where the tip of the tool is going to be focused on. So the curve type, we're going to go to 3D curves, select points, and we're going to select this top geometry. Make sure you're not in the solid geometry. Make sure you're in wireframe, and chain this geometry. Okay. Once that's done, hit green check. All right, and I'm going to leave it there for now. Okay, because I wanted to show you how to go back and change a start point later. So let's now compensation type. I'm just going to turn it off, and I'm going to turn the radial offset to off now. Okay. Everything else is okay. We're going to mess with distance later. All right. But let's leave that alone for now. This pretty much the tool path for the tip of the tool where it contacts the workpiece is pretty much set now. So now we have to get into tool axis control, and this is I guess you turn that like more of the back side of the cutter, the tilt of the cutter. Okay, pivoting on the cut pattern. All right. So for tool axis control, we're going to get in here and we're going to do plane, and I'm sorry, surface. And now we're going to select the 4 chamfer surfaces. hit end selection. That's all set. Now this is a flat cutter, so we're not going to have any lead or lag, angle, or side tilt. Okay, the angle increment we're going to leave that. That has to do when it's starting to tilt, and we're going to leave it to normal to surface. Okay, everything else is fine. Limits are going to be fine. Collision control, the tip control is going to be on projected curve. Everything else is okay. Vector depth is here if we wanted to, make this deeper or whatever. This is sort of like depth in linking parameters, I guess you could say. You could see the issue here. I'll show you what it changes later. So let's just leave that at 0 for now. Linking is okay. Entry and exit, we're going to update. This is your lead in and lead outs. So I'm going to make sure there's an entry and exit curve. And on this example, I'm going to change it to a length of 100% of the cutter and transfer it down. We are going to end up changing that to a thickness later on, but right now we'll leave it there. We have no roughing, not needed. There's your depth of cuts and multi-passes, sort of like contour. There's no need for filter here, and everything else should be okay. I will double check my planes, that is fine. And that should work right now. So we'll hit green check, and we'll see what we have. Now we have some multi-axis movement, okay? And it looks pretty good. There's your lead in and lead out. And let's just take a look at this run. Take a look at it in backplot. So we'll backplot this and hit play, and you'll see what occurs. Now again, the tip of the tool, notice, is centered on this line. Okay? So where we chain that controls the tip of the tool. The tool axis control controls the tilt out here, pivoting about this line. So again, if we go into parameters, your cut pattern controls the tip of the tool. The tool axis control controls the tilt. Okay. You can change the tilt by the side tilt angle. You could change that if you liked. Also on a ball mill, you can change your lead and lag angle to get away from the center point of the ball end mill. That will increase the efficiency of the tool, and it just gives a better finish. Okay. So typically, 5-10 degrees, something like that. I've seen side tilt, depends on your situation. All right. But these are more so, I've used these more with ball end mills or bull end mills. Really ball end mills more. These two. Okay. So we'll hit green check here. We'll regen. And again, we'll backplot. And watch this run. Now, one thing you could do, you could hit stop, and I'll show you this. This is the only time I use this. If you hit S, it'll skip to the next area. So I'm clicking S on the keyboard right now, and you'll see we can watch it tilt around here. See the tilt? So we get over here and hit S, and you can watch it pivot. And that's how you know you're pivoting correctly. Okay, so I'm hitting S, and that's just single blocking around. Okay, so that looks okay. Let's get an isometric here, and let's watch this and verify. And I have my precision way up to make sure I'm not getting any weird stuff on the corners, so we'll hit play. And it looks pretty good. Okay. And again, I guess there's no reason to do a chamfer like this. There's other ways to do a chamfer mill. This is just a real easy tool path. Just to show you some of the basics on this that go along with this simple part. So everything looks good. Okay, if we get in a simulation, I have the UMC loaded. And we can hit play. And it's going to go ahead and mill that. Pivot around. Alright, and it leads out. So that's a quick overview of that. Let's get in here and make some changes. So a lot of these moves, especially these ones, these little tips, are unnecessary. If we look at our code right now, if I just post this quick, I'm just going to post this one operation. There's going to be a ton of movement in between here that is sort of redundant and, in my opinion, unnecessary. So we get in here, normal stuff, unlock the table. You do have a dynamic work offset into here, and then you turn it off. Then you get into G234, which should be TCPC, okay, or tool center point control. and then it works in and starts moving around. So you'll see a lot of these straight line cuts moving around. They're not necessary. They're just moving along. Okay. Then you're going to see a G93, G94. That just changes when you start rotating to an inverse time feed rate. That's why these feed rates look so big. This is inverse time feed rate. And then a G94 turn inverse feed rate off gives you the normal feed rate and continue. So we don't need all those moves. This code is way longer than I guess it really needs to be. So let's change a few things with that. So to reduce the steps in the code, we go to parameters, and in cut pattern, curve following method, change the maximum step to like 5 inches, and hit green check and regenerate. And then you'll see that we've gotten rid of a lot of those lines, those vector lines. So double check my stock model, and we'll go to verify quick, and we'll take a look at what this looks like. And all the corners should look the same. They look pretty good there. Looks pretty good there. And this one looks pretty good. Okay, so let's take a look at the code now after that one change. Again, I'm just posting this Chamfer Toolpath group here. Okay, and you'll see the code is substantially shorter. You'll see that we have a movement. Come into the workpiece, go to movement, we end up stopping at 2.448. Then we get into the rotations. Rotates around, inverse time off. You have a movement. Okay. And you continue. All right, you could see X 2.45 and Y minus, and so on and so forth. So that will reduce your code. The next thing I want to show you is let's change the start point of this and change some of our lead in, lead out settings. There's our current lead in, lead out. Let's get into parameters and let's look at our cut pattern, and let's click this arrow where 3D curves is, and let's right click and start point on the chain. Right here is move dynamic, and I'm just going to snap to the midpoint of this line on the front and hit green check. Then let's just hit green check. I'm going to show you what that does quick alone, and you'll see the difference. The only problem is now is that it's leading in, leading out. It's in line, with what you're trying to cut. So it's not really a lead in, lead out. It's plunging right in. Okay, so let's change that. Get into parameters, and what I'm going to do is I'm going to go into entry and exit. The length I'm going to change to 0, and the thickness I'm going to change to like 150%, let's say. Okay. So now the thickness, the width, okay, right here is what we're changing, what we're dialing in on. Okay. So let's leave that there. Make sure they're both on thickness at 150% or 100%. That's fine too. We'll hit green check and regenerate, and you will see the difference. So now let's watch this in backplot. And it goes in right here. Leads in and goes. We'll watch it go around. And it'll lead out. Okay. A couple other tools in here that I think are useful. If we go into options, you can display your vectors. And you see our vector lines now. Okay, and in other types of toolpaths, you can use these as geometry and save them as a level. Here, you can save them as geometry if you want, and I've seen people use that to guide the tool around. There's a very good video that Mastercam puts out for that. Okay, so that's just another example. This is real simple; doesn't really need any other guiding around. But anyway, we'll hit green check, and let's take a look at any other settings in here that are gonna be relative to this. I'm pretty sure that's all I wanted to get into on this one. Everything else looks okay. Let's green check out of here, and let's watch this again in verify. And I'm just going to go to the simulation just so you get a better idea what's going on. All right. And I got this going slow. The precision's up, and it's going to go in the middle, work its way in, and start cutting around. All right. Last side. And lead out. Okay. And all these chamfers look pretty good. Make sure the precision is on. Okay, way up, not on, but way up. It helps. Again, if you have a poor graphics card, it is what it is. But you get the idea of what we're trying to show you here. Now, the other thing you would always do, again, backplot is very helpful. If we just fit this to the screen. I'm just going to go isometric here with this workpiece. Zoom out. And we can hit play. All right, and we can slow it down if you want. Hit stop right there. And then hit S, and we can watch it tilt and make sure that it stays right with this crisp chamfer line right there like that. Just like that. So it should pivot right around. Okay, you see it flies right across because there's no real need to increment around those flats, in my opinion. I think it just makes the code longer than necessary and gets you the same results. So anyway, that is a quick intro to the curve multi-axis toolpath. It's the first time that you're going to be exposed to a simultaneous multi-axis toolpath in this class. So we'll leave that there for now. I think that's good for this example. That gets into 3+2 and a little bit of simultaneous on the same part. It is fairly simple. We'll see how everybody does. And if you have any questions, let me know. Thanks.